Um, Now we will move to the last part of the workshop, last but not least, which is a talk from Professor Amit Seth. Amit is a founding director of AI Institute at University of South Carolina. He's a NCR chair and professor there in computer science and engineering. Hopefully Amit has, you're going to cover your bio a bit, but what I would say is that I've been part of that community where Amit has been a leading light. He has a leading role in semantic web and knowledge graphs community for a very long time now, and is considered an authority on the subject of neurosymbolic AI. So without further ado, I invite Amit to deliver his keynote. Amit, thank you very much.
Thank you very much, Dhaval. Um, I hope the situation in Chennai is improving. So some of you flew all the way there, and I'm sure looking forward to in-person connection. Get together, and that has its own unique value compared to just Zooms. But we are doing the best, I guess we can. Um, and what a wonderful gathering here. I saw some of the names, some of them I know, some of them I know of. So it's a great audience, and privileged to have this opportunity to present. Now, here's what I would title my talk. Why do we need custom, targeted, compact, and neurosymbolic AI models for health applications? So, in general, I'm addressing the narrow aspect of AI models that are suitable, the core AI technology that is suitable or not for health applications. Um, I, at the AI Institute, we are nearly 50 researchers, and we do a broad variety of things. And today, I'm going to focus on, what is at the center of that: neurosymbolic AI, explainable, explainability, safety, trust, ethics, interpretability, those kind of issues. And with the focus on couple of health application, or with using couple of health applications to demonstrate the need for next generation of technologies. We are our version. A lot of people are working on a lot of different things. The whole approach of work at AI Institute is that almost everything we do is has end user, customer, their data, their requirements, their engagement throughout the process of the projects we do. So our projects are almost always team projects, and involves always working with manufacturing, working with health. We can't work with health in isolation without clinical or a patient, or whatever the end user of the technologies, their involvement. So we had, in that sense, and we also typically build scalable systems. In the past, I have founded or co-founded four companies, three of them by licensing the technology that I developed in the lab. So that is a little bit of practical and real world situation. In this, I won't go through the outline here. The first part of the talk, I'm going to discuss, the generative AI technology, and notice that this technology in itself is not suitable as much for most healthcare applications. You train on massive amount of data. There is so much contamination of the data, uh, and you really the technology has been successful in a limited context and widely successful for some other applications, some of the applications. So, the applications that are what you might call generative AI for enabling generic AI for generic applications, that it does fine. But when you go to, applications that require decision making and taking an action, instructing the patient to do something, or deciding on a diagnosis or treatment plan, then it falls down. And There are number of reasons, but it starts with lack of domain-specific knowledge. In healthcare, for example, you must use medical guideline for that discipline. If you are practicing asthma, there are guidelines for asthma. If you are practicing mental health, there are guidelines and various uh, questionnaires and knowledge related to GAD-7 for anxiety and PHQ-9 for mental health. And to some extent, you can add these things through RAG and other things, but I don't have enough time to go through all the challenges when you try to just take the generative AI as a core and try to make slight improvement using um, additional work like RAG, prompting and RAG. One interesting thing to observe is that as you see how the generative AI is being used, you find that at least currently a lot of applications are information centric, and when it comes down to taking actual decision for an enterprise or industry application or for healthcare, they are not there. And one key reason is that this technology is not trustworthy in many, many different ways. The trustworthy and robustness are the two important things that it has been missing, and hence, for a class of applications, this technology is in itself not very relevant, or not very not adequate. There is another interesting thing that is happening, and more observations that the generative AI as it is now uh, is going to affect only a small percentage of jobs. So this is a very interesting video here. And this professor claims that AI can, and he means generative AI right now, the current AI can affect only 5% of the jobs. And he says that, look, for the high value business or industry, and I would add healthcare to that, applications, it is very hard to provide the accuracy, precisions, the faith and trustworthiness in the technology, and you need to incorporate the rules and the processes and other things that humans use currently to do their jobs. That is not done very well. A book has just come out last month, and Gary Marcus discusses several of the risks there. Some of them are quite relevant to some of the quite relevant to healthcare. We know the embarrassing failures like AI suggesting eating rocks and adding glue on pizza. But even it becomes more nuanced in that when you are communicating with the patient, it's important that the right language is used. Uh, okay, all right. So there are in healthcare, expect AI more. We need to tailor the AI models for clinical decision support, personalized treatment plan. For this kind of stuff, we need to advance the AI, and that's what I'm going to talk about. So I'll move on. Of course, I want to mention in passing that there have been some spectacular success too, as in radiology. But they typically are due to the advanced pattern recognition capabilities that's inherent in this technology. There are a number of reasons why generative AI is failing in medical aids. I listed some of them: limited accuracy. ChatGPT showed only 56% accuracy in medical queries last year. And this will keep on improving, but it's not done in a fundamental way. So if you add throw some more knowledge and still have real retrieval, that is not something that understands the knowledge, just use as a text, it doesn't do the job. A lack of domain specific expertise, and the domain specific expertise is specific to that domain. It's very hard to rely on a core use of a massive trillion parameter large language model and then try to, that is meant for, blunt effect, treating, supporting a lot of different people, and address the very concrete and challenging issues related to one patient. The I mentioned earlier, there are, if you want to practice in medicine, there are guidelines. You must follow that. The doctor should be comforted in knowing that the AI system is actually using the guideline and adhering to the guideline in giving whatever suggestion is giving. Otherwise, they will be subject to poor decisions, subject to legal actions, and so on and so forth. A lot of challenges with the bias and other things also. Um, all right, so here are some of the uh, uh, requirements. When you want to use AI for decision support application or take actions related to human health. One is personalization and user alignment. So you have to meet end users' need, you have to meet clinicians' need, and that means that you have to provide specific knowledge about the patient or give the patient context. In 2018, we had introduced a term called personalized health knowledge graph. So all the, any information about the patient, such as the one that is in an EMR, would be captured as part of the knowledge graph and used in all the interactions. Grounding in declarative and process-based domain knowledge, I mentioned that already. Instructability. So the clinician's feedback or guidance must be incorporated. It's very hard to build AI system that has entire context, and you have to, and so the human engagement would be very important. Thus, I would say that yeah, we can build chatbots for some simpler applications. We need to build co-pilots with the ability for humans to experts to engage. And then I don't think we are yet very ready for using autonomous agent for many AI applications for now. So from a broad perspective, after the symbolic AI of the last century and statistical machine learning and going through the deep learning, going through the generative models of this century, we are ready to now explore the next major step in AI. DARPA calls it phase 3 of AI. And there are different terms. I'll express this in terms of neurosymbolic AI. Okay, so to start with, I want to share with you. Trouble sleeping. Here is similar information can be seen in the back end. Here is a system that we had built and partially evaluated, where the conversation is understood in the healthcare context. So there are knowledge graphs, and that as the conversation proceeds, it is explicitly showing you what is the concept being talked about, what is the relevant knowledge that is being used in coming up with the next conversation and such. Right now, when we did this, it supported us really with the personalization, with user explainability. So there's a lot of work in AI for system explainability or how the algorithm functions, but here we have to the AI system needs to tell the user in the language that the user understands, separately for clinician and for patient, how the AI system came to this step. And then safety. For example, while I don't have time to give the demo fully, here the AI system, generative AI, driven system, comes up with a response that could make the patient think of suicidality, and that is a wrong thing to do for this particular patient. So such outputs and communications must be prevented. It should be appropriate to the patient condition and context. So those are the kind of things that we try to we demonstrate in this uh, project. Now we are moving on to some more complex projects, and in that context, I'll have opportunity to discuss some higher end requirements and the research being done to support them. So, in state of South Carolina, the government passed a law in 2018 that there will be this framework called multi-tier support of networks, as multi where for to provide behavioral health assistance to school students. So in there are literally hundreds of students assigned to one single counselor, and post COVID there were 1,300 students per counselor. Clearly doesn't scale, and ability to hire new counselor is just simply not there. So that's where a clear if AI can help, that this kind of things, it will be a great example and a great place to apply AI. One of the interesting thing here is that you have various humans with different roles: school counselor, district counselor, school administrator, parents, or caregivers. So the AI system needs to align with each of them. Each of them are doing different tasks, and when you uh, uh, a particular user needs to have contextual alignment with the AI, or AI system needs to have alignment with particular class of user. I show that in top left. Um, so it should be aligned with diverse roles, and I showed some of them here. And there are other things. For example, therapeutic decisions need to be balanced with cost optimization and side effect minimization. There's a small amount of things. So there are protocols that define this, and we need to use those protocols, adhere to this protocol. So some time ago, we defined the concept of process knowledge. And the medical guideline would be an example of a process knowledge to be used in diagnostics or treatment planning, and that must be utilized. And in a stepwise manner, doctor may is trained to say, okay, I need to rule out this, I need to give this lab, and based on that, I need to do the next test, and then come to the conclusion. So that process has to be followed. Current generative AI is not quite optimized for those kind of things. Then when you look at this application, you'll see that there are quite a bit of requirements, and you can always think at the back of your mind, is current AI ready to support all of these things? But we need basically AI that is grounded in knowledge, instructable by experts, aligned with end user expectations, supports reasoning and planning. I show reasoning planning needs on the top right of the P figure. It should be consistent. It should be results should be interpretable, and it should of course support safety of all involved. So we break down the system in a number of small modules dealing with all of these different things, and you can see various components and such. There is a detailed video that can instruct that. But as we looked at this class of applications, you can look at all these hashtag items: grounding, instructability, alignment, explainability. So all of these things are very important. Thankfully, I run a department in IEEE intelligence systems, and other, we written articles on each of these things, and giving examples. In many cases, examples are from healthcare domain. Essentially here we have, sorry, essentially what happened here?
I think all is good. We can hear you.
All is good. Okay.
Yeah,
Hi.
screen is fine as well. Yeah.
Okay, great. So what needs to happen is that we need to combine the system one kind of thing that Daniel Kahneman talked about, which is based on neural net technology, with system two, that is a symbolic technology. And these things have to be integrated in a very fish with care, with a lot of and knowledge plays extremely important role in combining this system 1 and system 2. So when you are, for example, trying to understand what I'm saying, you are using your lexical knowledge, linguistic knowledge, common sense knowledge, general knowledge, purpose knowledge, and domain specific knowledge, right? uh, how do you expect, and so our argument is that you would have to incorporate appropriate knowledge along with some of the techniques that come from symbolic AI world to and with the power of dealing with very large amount of data in the generative AI to get appropriate solutions. So the knowledge infused neurosymbolic AI is a particular type of neurosymbolic AI where we particularly focus on, and there we develop a broad variety of techniques that connect neural networks and deep learning with knowledge graph and knowledge base computing. I'm just flashing this slide. I won't be able to describe in detail, but there are a whole class of algorithms that have been developed, and the reference at the bottom discusses this in more detail. Among the most important things to make the robust AI are instructability, grounding, and alignment. I'm going to pass on. And then, building a trustworthy AI requires these things about consistency, reliability, explainability, safety, and trust. And we discuss them in some of the papers in lot more detail. So, okay, I'm going to move on. Explainability is very critical, and not just for the user, is for, it needs to be for user, not just for the alignment. So here I'm just giving one example that if you ask explainability using current state of the art technology, you'll get some very generic answer. And what you need to do with using neurosymbolic is that you really, by using domain knowledge and understanding what this understanding the conversation and exchange, you'll be able to tie to specific medical concepts and what they mean, as I try to show in the bottom right. So in this particular case, we know that this is a depression related things, and we have domain knowledge related to PHQ-9, which is used to diagnose or characterize depression, and that the results are in incorporates that particular knowledge. Now I have a couple of very I have several uh, applications, but for the because of the time, I'm going to give a snippet of that. And in the slides there are longer videos available, but to see, so we'll go with the snippets. So here is the first one.
Every meal impacts your health, so why not make every choice count? Introducing Nourich, your personalized AI co-pilot for smarter eating. Powered by a custom, compact, and neurosymbolic model, it offers real-time personalized dietary analysis. Nourich is a specialized AI model for food and nutrition. With access to millions of recipes and semantically grounded knowledge from diverse sources, including disease-specific insights and personalized health information, it offers tailored meal recommendations and recipe modifications designed to meet your unique needs. With the power of the Common Metadata Framework, in collaboration with HP Enterprise, we ensure traceability and AI governance, so you know every decision is safe, transparent, and trustworthy. Nourish is more than just a recommendation tool. It's your trusted co-pilot for healthier living.
Let's look at another one.
System of supports. MTSS is a 3-tiered proactive intervention system designed to help schools support students through key components like universal screening at the start of the school year to identify student needs early, tiered interventions that adapt in intensity based on student progress, continuous data collection for ongoing assessment and improvement, a school-wide approach to consistent expectations and supports, active parent involvement to ensure holistic student growth. The MTSS team is a collective effort involving teachers, counselors, mental health support staff, administrators, and more, all working together to create a supportive learning environment. But what if an AI system could enhance this teamwork? That's where the MTSS AI system comes into play. To meet the specific needs of the AI system, we have three unique features: custom, compact, and neurosymbolic. Let's break down how these elements work together. The system is custom built, trained on domain specific data to act as a specialized concierge. It's compact, made up of small modular components like user specific copilots tailored to each MTSS team member's role, reasoning, planning, and search systems that incorporate both neural networks and symbolic AI to facilitate alignment and instructability through human expertise. Feedback mechanisms and dynamic knowledge update to keep the system at par with the ongoing interventions. This hybrid AI approach, blending neural networks with symbolic systems, is not just innovative, it's built with safety in mind. Grounding the system in human expertise ensures that recommendations are reliable, consistent, explainable, and significantly less prone to errors or hallucinations. Designed for schools, this system is aligned with AI safety principles by tailoring its copilots to the needs of educators, counselors, and administrators.
Okay. So now I'll go towards wrapping up. What we um, there are three very important components of our approach. First is custom or targeted model. We what using a large language model or foundational model trained on data that you have not curated, that you cannot necessarily depend on, has led to a lot of different problems. And here we so in the MTSS, for example, we have access to years of conversation activities that has actually happened between the healthcare worker and student and users, and that allows us to have a very good corpus on which to train our model. So we want to really enhance the accuracy and relevance. Other thing is we want to given that you're not training on common crawl, the cost is far smaller, far smaller, and there is added security and privacy. You can customize it to the particular needs and align. The smallness, which is a kind of very related concept, is that it can be deployed on a mobile phone for the user, or a computer at the clinician's practice, wherever you want. So this is deployable on the edge. And this is different than recent surge in growing small models, where a large model is built and you try to make it smaller, or you do other various techniques are there, whether you do X bit or Y bit, and that has a very different purpose in terms of making it compact versus what we are doing here. And the last one is the neurosymbolic part, and creating a platform that there are a lot of moving parts here, right? There are a lot of things about data, about knowledge, and about human expertise. All the three are getting their due share, compared to the data alone is so powerful that it will do everything you want. We don't believe in that. We need to really we need to really combine all this data, knowledge, and as you saw in the nutrition example, there are multiple knowledge graphs involved. There are other examples where multiple modalities are involved. We have one for smart manufacturing that has sensor data, images, and text. Variety of data is involved, variety of knowledge, multiple knowledge sources are involved, and knowledge graphs involved. And not only you use human to improve the results, such as RLHF or DPO does, but you also use well-defined verification system, and do verification before you deploy any system. So bringing all these three together, we are developing this streamlined small scale models that reduces computational overhead while maintaining high performance and quality. I think this is going to be, put one approach, and others will come about for what I very much expect to be very high growth in developing specific models for specific applications, so-called industry specific, task specific, enterprise specific models, as we go forward. And that, we that there in this context, I think AI can serve more of the needs than current generic AI can do. Okay, so takeaway is this following, um, and I think you can read there. In the end, AI models should be trustworthy, support grounding, environment, stability, reliability, consistency, and so on and so forth. And there is a lot of what it. One thing you can take away is that there is a lot of expectation on an AI model, and many of these cannot be supported well with the current technology. So there is still a lot of work ahead for us AI researchers and AI application people who engage in applications. More technical details are in elsewhere, and of course, none of this is done by me alone. I have a good team here. Yushin helped particularly for this particular slides. Okay, so I think I've completed in less than my time. So hopefully you can have time for questions.
Yeah, we certainly do. Thank you so much, Amit. We have about 7 minutes to ask question. There are two questions. Both of them are from Hull team. But Pupesh, if you don't mind, I'll do it out of turn. I'll bring Maniha first. So Maniha is a PhD student who works on neurosymbolic AI just in the first year, and she has some specific questions. Maniha, would you like to, if Gokul, if that's okay, to turn on her mic, and if you want to ask your questions one by one, Maniha?
Yeah, thank you very much, Dr. Dhaval, and thank you very much, Professor Amit. Since my PhD is highly aligned to the work that you were presenting here, so I have lots of questions. I would like to keep them brief. Since in neurosymbolic AI, there are lots of frameworks, including deep problem, LTN, logic tensor networks, kind of things. So, do you recommend me using any neurosymbolic framework integration with large language models? Specifically at any algorithmic level. I have been through certain approaches, but some of them were either theoretical, most of them were either theoretical, or if they were practical, they were being integrated at only post inference stage. So, for example, logic based frameworks were being integrated in post training stage, and it seems very easy and like straightforward thing. So I hope I'm concluding it right, and if it's not clear, I'll repeat it again. So my question specifically is, do you suggest me to recommend any neurosymbolic framework to integrate it with LLM at a specific integration stage, and that too at algorithmic level?
So all sort of approaches have been developed, just very weak integration between the two classes of system, uh, logic based thing, approaches, and they are covered here in this diagram and the discussions. And there is a physics based approach also, and then there is a knowledge enhanced approach. We pursue, and we are focused on developing the knowledge centric approaches, not the logic centric approach, for a number of reasons. I worked with logic for many years. My first AI project in 1988 was logic and base, but basically they don't scale, and the type of knowledge and the degree of knowledge that can be captured in as logic is far more limited compared to how we capture as knowledge graphs. There's been long debate even in the semantic web world about whether you should take an owl centric approach versus RDF or property graph centric approach. And by and large, you should know that the latter has won. And the same thing is going to happen here. I personally don't see how the logic representation based method are going to work very well. Especially you look at the examples I presented, there is fairly significant amount of knowledge. And for you to sit and capture all that knowledge in as logic and axioms, it's not going to be it's going to be extremely hard and very costly and such. The knowledge graph, where graph is underlying representational, is the proper I guess say compromise between scalability and expressiveness. The expressiveness versus scalability trade-off has been age long. I mean, it's been always there, and picking the right part there is very important. I favor approaches that are adequately expressive, and using less expressive approaches where the application requirements cannot be captured very well, to me doesn't make sense. Then you're not going to get full results, comprehensive results. The other point I would like to make is that yes, there are we can start with a large language model and add to that some knowledge base enhancements. And LLM plus KG is a the lot more. There's a lot of work going on in that area. A lot of papers have come out recently. I am interested in, and our work has, so we that's how we did earlier on, and our paper in the in 2017, 18, 19, 2020 until 2020, 21, we did that. But last 3 years we are much more focused on creating the model from the scratch. So we don't, or we may use the open source model in a limited way to construct the language. Large language models are needed and extremely good at creating language that is hard to distinguish from human generated language. And such use of the large language model capabilities for such specific needs is very appropriate. But by and large, much of the application related things, the reasoning that has to go on, the alignment with the knowledge that has to go on, that is all done within the model that we create from scratch. And given that we are solving a specific problem much better than a broader problem, many problems that large language model can solve in a mediocre way. I would, I think we are focusing on the first type of system. So obviously the models that we are building are not going to, the mental health application model that we have built is not going to work for some, some other domain, right? It's going to work just for that. And to me, that is the right. Many people have understood that accuracy of 90% is not adequate for many applications. And even that 90% that is shown, or 95% that is shown, is with benchmarks that are really not good enough for that. In many of generative AI systems, results look impressive on paper, and in for real world they don't work very well. The example of 56% accuracy in ChatGPT on clinical question is just case in point. So I think people will have to take a very deeper. Will have to take deeper benchmarks or test sets and evaluate. And at that time, you'll see more and more that large language models by themselves cannot solve the specific problems very well, and that simply building on the large language models with its inherent property of hallucination and other things that there's nothing you can do. The tech. the neural network technology is such that hallucination is part of this thing. It comes with it. Then all the effort that you have to do to harness that, to remove that, to identify, remove that, is a way too time consuming and costly in a computational way also. We had a paper in the last EMLP which won the outstanding paper award, that was about the difficulty in telling whether the model the text is generated by model or by human. So okay, I hope I covered your question.
Thank you.
Yeah.
Thanks, Amit, and thank you, Maniha. I have a difficult job of choosing just one question out of three because of the time, but I'll go with Will's question. In the UK and EU, this type of technologies would likely be classified as software as medical device, and so would require regulatory approval before you can sell and they can be adopted. I've been thinking about how difficult it is to evaluate the performance of these technologies, which would be a prerequisite for regulatory approval. Any thoughts you have on this would be good. And he has provided an example of your specific Nourish app as well. But yeah, I think you got the gist of the question. Yeah.
Right. So let me, we have a paper on just this topic, or it's very related to this topic. So in the paper titled Neurosymbolic Value Inspired AI. And here the aspect of the value is that any in a society, and in a system meant to support humans, or that involves human, you have laws, you have regulations, you have policies, you have guidelines, and we humans are subjected to those. So the AI system has to be subjected to this also. And so here our argument is that you need to capture those value specifications in symbolic manner, and build the AI system that would adhere to, that will ensure that those regulations or guidelines are followed. So here is a essentially so in your particular case, indeed you'll have to concretely involve regulation as part of the system itself, meaning the regulation must be consulted as the computation goes on. And that's what this thing argues for, and that's what this paper or article discusses, how you can go about doing that. One very specific way here is that there are guidelines that are very specific mental health related guidelines, specific one very interesting example is that if your patient has come for mild depression, you do not want to interrogate the patient for suicide related concepts. That is against the medical practice kind of thing. Hence, such a guideline must be encoded, and your system must be shown to adhere to or follow those guidelines. So this is how we will proceed towards building systems that will be I think that will be ready for regulatory compliance, because yeah, these are all the things here, all the regulations are here, all the guidelines are here, and I can promise you on here is how the system works, and this is the context in which there is a potential failure, but failures are not catastrophic, and that it serves 99% of 99.99% of the things well. That kind of things we'll have to build as you go along. I hope I answered that.